Hello and welcome to IGCSE Physics again, and today we're looking at the astrophysics topic, in particular orbits. So what are we going to learn today? Well, there's going to be three clear learning objectives. The first one is understanding about gravitational field strength and how it changes on different planets. Explain that gravitational force causes various things, and then describe differences in the orbits of comets, moons, and in planets. So the first thing is, where are we? So the solar system consists of the Sun, orbited by 8 planets and their moons, some dwarf planets, with many asteroids and comets. So we're on planet Earth, which is the third rock from the Sun, and it consists of those 8 planets, which we're going to look at now. Okay, so the planets, what is a planet? So a planet essentially is something or an object that orbits the Sun, but it is big enough to have its own gravity, just like the Earth, and that makes it round. Okay, so it has to be a round object, and it has basically cleared its neighborhood where it's orbiting of smaller objects around its orbit. Okay, so for our solar system, there is 8 planets, or are 8 planets. Mercury, Venus, Earth, which is us, Mars, the red planet, Saturn, Jupiter, the massive gas giant, Uranus, and Neptune. And that's the order is there on the slide of their distance from the Sun. So Mercury is closest, and Neptune is the furthest away. There's also the dwarf planet. So a dwarf planet is again a object, a celestial body, so something in space that orbits the Sun, that again is big enough to be spherical, but it's not cleared all its neighboring region of other similar bodies. So there's basically, as of now, there are 5 dwarf planets. There's Ceres, Pluto. Okay, so when I was learning astronomy, Pluto was a planet, but now it's been moved into being a dwarf planet. Haumea, Makemake, and Eris, which is the largest of the dwarf planets. And there's a picture of Pluto there with one of its moons, Charon. We also have asteroids. So an asteroid is again an object in space, which again orbits the Sun, but it's not big enough, not massive enough to have its not being spherical due to its own gravity, so it's kind of different shapes. And most asteroids in our solar system are found in the Van Allen belt between Mars and Jupiter, also known as the asteroid belt. And there's about nearly 1 million asteroids, which are larger than a kilometer across in this belt. Okay, and I don't know if you've seen many of those disaster movies, but one of the disaster movie kind of tropes is the destruction of Earth by something called near-Earth asteroids, which pass very close to the Earth, and if they pass too close, they destroy all life. It's one of the theories of what destroyed or killed off the dinosaurs. Okay, and then there's moons. So a moon orbits the planet. So our moon, very creatively named, is called orbits our planet, the Earth, and there is a list on the table of the number of moons. Okay, and as we saw with Pluto, Pluto has its own moon called Charon. So dwarf planets and asteroids also have moons. And as I said, Pluto has 3 moons. An important aspect about orbits is the idea of the time period, capital T. And that's how long a year is basically on that particular planet. It's how long it takes to rotate, for that planet to rotate around the Sun once. So Mercury's quite close, quite fast, 88 days. We're a whole year, obviously. Whereas Neptune, a year on Neptune, an Earth year is 1 year. But to rotate around the Sun once, Neptune takes 165 years. So no one would have had their birthday yet in the class on Neptune. And this is all based around the concept of gravity, which we've already learnt about in the forces topic. And it's basically what causes the orbits of these different celestial bodies. And there's 3 things that you need to know about gravity. It's always an attractive force, so objects are attracted to each other by gravity, not repelled. Basically, it increases as the mass increases between objects. Okay, so the Sun's very massive, so it has a very strong gravitational force, whereas the Earth is a little bit smaller, so it's a weaker gravitational force. And also it decreases by a factor of 4 between gravitational objects or celestial bodies. Okay, so it gets stronger the larger the mass, the more massive the object is, and gets weaker by the distance the objects are apart. Okay, so it's all based around G, gravitational field strength, which you've also been familiar with, and the red thing is the most important thing there, that the gravitational field strength is equal to the gravitational force exerted per kilogram. And so for us on Earth, on the surface, it's around 10 newtons per kilogram. Okay, and we can also interchange that with the value or the unit of meters per second, because it's also the same as the acceleration that is due to the gravitational field strength. And this gravitational field strength, due to different sizes of the planets, is different on different celestial bodies. So the Moon, it's quite weak, it's about 1.6 newtons per kilogram, where on the Sun, because it's so massive, it's about 270 newtons per kilogram. And Pluto's really small, so it's about 0.7 on Pluto. And in terms of the differences between, say, orbits of planets and orbits of other celestial bodies, the orbits of planets are slightly squashed in terms of circles, which we call an ellipse, with the Sun kind of in the center of that orbit. Okay, so we can see that from the diagram. So the Earth orbits around the Sun, not the other way around. And this means, because of that kind of squished ellipse nature, that planets move more quickly when they are closer to the Sun and slower when they're further away. Now, obviously, this diagram here is very, very exaggerated. The orbit doesn't look like that. But in terms of the numbers you're using, that's still observable scientifically. Okay, so note that diagram's very exaggerated. And then what would happen if there was no gravity to our orbit? Well, here's a planet, that little red dot, say it's the Earth, and if the Sun suddenly disappeared, then what would happen? Then it would continue, the planet would continue to move out on a tangent at right angles to the original orbit that it was taking. Okay, and race off into space. And finally, to compare that with the other celestial body, the comet, in terms of its orbit. The comet is basically an object made of dust and ice. Okay, and you can see that the ellipse, unlike the orbit of a planet, is a lot more stretched out, more elongated. Okay. And you can see what happens actually, because it's made of ice, that ice melts as it gets closer to the Sun, and that causes a tail to form, which you can see in the image there of Halley's Comet, which I took in 1986. I'm that old. And you can see it gets close. As it closer to the Sun, the ice melts and forms kind of a tail. That means comets are more visible the closer they get to a Sun. And comets are quite small. They're about 1 to 30 kilometers in diameter. So that's the beginning of the astrophysics topic. And I hope that you have been teased as to what is actually a very interesting topic.